Welcome to Tomorrow Unveiled.
Great to be here.
This week, we're diving into, well, just an incredible amount of activity happening up in space based on the research our team pulled together. Have you ever wondered what's really happening up there, beyond the headlines?
There's always so much more going on.
Exactly. So today, our mission is to unpack the really important developments from just the last week or so. We'll pull out some surprising facts and figure out what it all means for you, the curious learner. We're not just talking about, going farther. It's more about building smarter, safer, more resilient infrastructure.
Yeah, building for the long term.
Okay, so kicking us off, let's talk about this mysterious messenger. Interstellar Object 3IA TLS. Our research team flagged this as a major scientific focus right now.
Oh, absolutely.
It's only the third confirmed interstellar object, right? And this one seems, way more promising for study.
That's right. And here's where it gets really interesting. Its discovery. It was first picked up July 1st, 2025 by the ATLA survey down in Chile. And what immediately stood out, based on the data we reviewed, was its path. Highly eccentric, hyperbolic. Meaning it's absolutely not gravitationally tied to our sun.
It's a confirmed, basically.
A visitor from another star system just passing through.
Wow. And what a visitor. The research emphasized its speed. Something like 130,000 miles per hour.
Around 209,000 kilometers per hour. Yeah. Just staggering speed.
That makes it the fastest object ever recorded visiting us, right?
By far, yes.
Does that speed tell us anything, about where it came from or its journey?
It does, actually. That kind of velocity suggests a really long journey, billions of years, potentially, through the Milky Way. It was likely flung out of its home system, maybe by interactions with other stars or, even black holes.
Billions of years. Incredible.
And speaking of the object itself, the size estimate has shifted a bit.
Oh. What did they think initially?
Initially, ground observations suggested it could be quite large, maybe up to 20 kilometers across.
That's significant.
But then Hubble got a look. High-resolution images on July 21st.
And
They refined the estimate down quite a bit, somewhere between, 0.32 and 5.6 kilometers.
Okay, still pretty big, though.
Oh, yeah. Even at the smaller end, that confirms it as the largest interstellar object we've detected so far. Gives us a much better target to study.
Now, here's where our research team found things get really intriguing. Its composition. It sounds like a bit of an enigma.
It really is. On one hand, there's good evidence pointing towards it being a comet.
Like what?
Well, observers saw a visible coma, that pear drop shape, and a faint tail.
Okay, classic comet signs.
Exactly. And spectroscopy detected water ice grains, water vapor, hydroxide ions, textbook commentary activity.
There's always a but, isn't there?
Hey, seems like it with this one.
Yeah, but then Japan's semi-telescope observed its surface, and it was extremely red.
Red, is that unusual for a comet?
Very. It's not typical for most comets we know, but it is characteristic of D-type asteroids.
D-type, those are the really old, primitive ones, right? Rich in organics. Precisely. Some of the oldest bodies in our own solar system. Dark, full of complex organic compounds, maybe the building blocks of life.
So it looks like a comet, but has the surface of an ancient asteroid.
Sort of, yeah. So the leading idea now, based on all this data, is that it's some kind of hybrid object, maybe an ice-rich body deep down, but its surface is coated in these complex organic molecules.
Huh. So it really blurs our neat little categories we use for things in our own solar system.
It definitely does. It raises that question, doesn't it? Are our definitions just too narrow when we encounter things from, somewhere else entirely?
So this thing acts like a comet, looks like an asteroid on the surface. What about its origin story? Does the data give clues?
Well, connecting the dots, its trajectory points to an origin in the galaxy's thick disk.
Thick disk. What does that imply?
It implies it's likely really, really old, ancient. Maybe 7 to 8 billion years old.
Whoa. That's twice the age of our solar system.
Roughly, yeah. Imagine that. A cosmic relic that's been traveling possibly that long, carrying the pristine chemical signature of another much older star system.
It's like a time capsule.
Exactly. A time capsule from the galactic dawn, almost. Offering direct clues about how planets formed around other stars, what they were made of.
Understandably, the scientific community is all over this. The research shows a big campaign underway. Webb, TESS, SWIFT.
Yep, all the big guns are being pointed at it, especially as it gets closer to the sun later this year, around late October. That's when we expect the best data.
Any chance of sending a probe? Like intercepting it?
Well, it's tricky on short notice, But ESA's Comet interceptor mission, launching in 2029, is actually designed exactly for targets like this. It's just a bit too late for 3 eyepieces.
Ah, okay.
There is some speculative talk, a proposal maybe, to repurpose NASA's Juno spacecraft, maybe for an intercept near Jupiter in March 2026. But that's still very much up in the air.
Still pretty exciting possibilities.
Absolutely. And the bigger picture here, you're detecting 3 of these interstellar objects just in the last few years, compared to 0 before 2017.
Yeah, what does that signify?
It really shows we've crossed a technological threshold. We're moving from just, like, rare surprise discoveries to potentially starting to systematically catalog this whole population of wandering galactic objects we couldn't see before.
A new age of interstellar astronomy, basically.
Yeah, you could say that. Studying the building blocks of other star systems firsthand, maybe even visiting them eventually, it's a huge shift.
Incredible stuff. But okay, let's shift gears. The future isn't just about visitors from afar. It's also very much about what we're building, how we're establishing ourselves out there, which brings us to some really cool advancements our research team highlighted in orbit manufacturing and infrastructure.
Yeah, this is where things get really practical, building that sustainable presence. The breakthroughs in space manufacturing are pretty significant. We've seen projects like ESA's Stargate successfully demonstrate 3D printing functional metal parts in microgravity.
Right, printing tools and components right where you need them.
Exactly. But what's really transformative, looking at the upcoming SpaceX resupply mission, CRS-33.
Okay, what's heading up?
Some groundbreaking bioprinting experiments.
Yeah.
One from Auxilium Biotechnologies. They're sending up materials to print nerve regeneration implants.
Nerve implants made in space.
Using living cells and proteins, yeah. The idea is microgravity might allow for better, more complex structures for treating traumatic injuries.
Wow.
And another one from Wake Forest Institute of Regenerative Medicine, focusing on vascularized liver tissue. They're specifically looking at how blood vessel networks, vasculature, forms in microgravity. That's absolutely critical if you ever want to build larger, complex organs.
Growing organs in space. It still sounds like science fiction. Why is microgravity the key there? What does it enable?
Well, here on Earth, gravity kind of pulls everything down, right? It limits how cells can assemble into really intricate 3D structures. In space, without that constant pull, cells can aggregate differently, potentially forming those complex networks like the tiny blood vessels needed for organs to function.
So it's not just a demo, it's using space to overcome fundamental biological limits we face on Earth.
Pretty much. It's early days, but it's laying the groundwork for potentially revolutionary medical treatments down the line. And that same mission is also carrying more metal 3D printing experiments, continuing to optimize that process.
Makes sense. Reduce the need to launch everything from Earth.
Precisely.
And supporting all this manufacturing are leaps in materials science, right? The research pointed to new alloys, titanium aluminide, nickel superalloys.
Yeah, and magnesium lithium alloys too. The push is always towards lighter and stronger materials that can handle the extreme temperatures of space.
I saw a note about a NASA Glenn breakthrough, something about 3D printable materials hitting 2,000 degrees Fahrenheit.
That's the one. Imagine what that enables for spacecraft design, for engines, making things tougher, lighter, more capable. It's fundamental.
And all this ties into building a more sustainable space environment, doesn't it? Like a circular economy.
Absolutely. That's becoming a huge focus. A landmark example our team flagged is the partnership between Zona Space Systems and Astroscale.
What are they doing?
Zona is putting standardized docking plates on all their new Pulsar satellites.
Okay, docking plates. Why is that a big deal?
Because it opens the door for the future. Servicing, refueling, repairs, upgrades, and crucially, controlled deorbiting at the end of life.
Tackling the space debris problem proactively.
Exactly. It's designing for sustainability from the start.
Yeah.
Hugely important for the long-term health of, Earth orbit. And you see other collaborations building on this, like Argo Space and Infinite Orbits, showing the different companies' tech can work together. Interoperability is key to building that whole ecosystem.
Right, you need common standards. Okay, what about getting around up there? Any propulsion news?
Oh, yeah. Lots happening. One interesting trend is water-based thrusters. Mitsubishi Electric investing in a company called Pale Blue really validates this green propulsion idea.
Green meaning?
Safer, less toxic, less costly than traditional propellants like hydrazine, especially good for smaller satellites. More environmentally friendly, too.
Makes sense. Responsible operations.
And then there's the speed of development. Get this. Agile Space Industries developed, and Hotfire tested a new 3D printed thruster for a vehicle called Nix in just 10 weeks.
10 weeks from design to test.
Yeah, shows how rapid iteration 3D printing, it's really changing the game in propulsion development.
Any other big propulsion advances noted?
Yeah, a couple stood out. RTX is working on a rotating detonating engine, which could offer like a 25% gain in fuel efficiency. That's huge. And NASA put out feelers, an RFI, for a 100 kilowatt fission power system for the moon, needed by the mid-2030s, and critically, weighing less than 15 tons. Powers everything for long stays.
Definitely. Power and propulsion are key enablers.
Yeah.
Okay, quick pause here. If you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you can leave us a rating and review for Tomorrow Unveiled. It really does help us reach new listeners.
Please do.
All right, moving on. This past week wasn't just about science and manufacturing. It was also pretty pivotal for national security in space and commercial capabilities, too.
Absolutely. A really significant flight happened.
You mean the Vulcan Centaur launch, USSF 106.
That's the one. August 12th. ULA's Vulcan flew its first national security mission, and it was flawless. This flight formally certified Vulcan for the big National Security Space Launch Program.
Which means
the U.S. officially ends its reliance on those Russian-made RD-180 engines for these critical launches. It ensures sovereign access to space. A big strategic deal.
And the payload was interesting too, right?
NTS-3.
Extremely interesting. NTS-3 is an experimental navigation satellite, the first new kind of experimental navsat in nearly 50 years.
Wow. What makes it so different? The key things, according to the research, are its reprogrammable architecture and its phased array antenna.
Okay, break that down. Reprogrammable architecture. Phased array antenna. What does that really unlock?
Okay, so reprogrammable means it's not static. Unlike older satellites where the function is fixed at launch, NTS-3 can be updated in orbit. Think software updates. They can tweak its signals, counter new jamming techniques, maybe even adapt it for completely new tasks later on. It's like upgrading your phone's OS, but for a satellite.
So it can evolve to meet new threats.
Exactly. And the phased array antenna lets it electronically steer its signals. It can focus power where needed, making it much, much harder to jam compared to a traditional fixed antenna.
That sounds like a fundamental shift from static assets to dynamic, adaptable ones.
Precisely. It's designed for resilience in what's becoming a more contested space environment.
And it's not just navigation getting upgrades, right? The missile warning satellites, too.
Correct. Lockheed Martin's next-gen OPRG-EGO satellites, the new missile warning system, successfully passed their environmental tests.
Yeah.
They're moving closer to launch.
How are they better than the current system?
More sensitive infrared sensors, for one. Better detection. And they're built on a hardened combat bus, basically. A tougher satellite structure with enhanced resiliency features baked in. Again, the theme is survivable dynamic platforms.
Okay, shifting to the commercial side, what innovations stood out there?
A couple of neat things. ICEYE, the radar satellite company, rolled out a new imaging mode called Scan Wide.
Scan Wide?
Yeah, it's a software update, basically. It lets a single one of their satellites capture a huge area, like 60,000 square kilometers in one go, though at lower resolution, about 27 meters.
What is that useful for?
Broad area monitoring. Think tracking ships over large ocean areas looking for dark vessels or spotting oil spills quickly. And the cool part is it has a tip and cue capability. So if Scan Wide spots something interesting,
You can zoom in.
Exactly. They can task the satellite to take a super high-resolution image down to 25 centimeters of that specific spot for a closer look. Very powerful combination.
Interesting. Anything else major on the commercial front?
Yes, OQ Technologies' 5NetSat mission. This is a big deal for connectivity. It's Europe's first actual on-orbit demonstration of a 5G non-terrestrial network, or NTN, operating from low Earth orbit.
So 5G from space, directly to phones.
Directly to unmodified standard smartphones. That's the key. No special equipment needed on the ground.
That could be huge for global coverage, areas with no cell towers.
That's exactly the goal. Ubiquitous global connectivity, independent of ground infrastructure, a really crucial step.
And the research also mentioned China's lunar lander tests and Ariane 6.
Yeah, just briefly, China did a full-scale test of their Lanyu lunar lander, aiming for a crewed landing by 2030. So the lunar race is definitely heating up. And Europe's Ariane 6 had a successful launch, deploying a weather satellite. So progress across the board, really.
Lots of activity. But with all this progress, there are always challenges, right? What does the research say about the hurdles we face?
Yeah, you can't ignore the challenges. And the big one that keeps coming up is space debris.
Still a major issue.
Getting worse, actually. The latest ESA Space Environment Report from 2025, which our team reviewed, highlights a rapid increase in objects in LEO. The worrying part is, in some busy altitudes, the density of active satellites is now similar to the density of existing debris.
Meaning the chance of collisions is going way up.
Dramatically.
Yeah.
It's a critical threat to everything we're trying to build up there. Needs constant management.
But are we seeing solutions emerge?
We are, thankfully. The commercial sector is stepping up. Companies like SeaOps and Digantara are offering services to track objects right after launch, down to like 5 centimeters in size.
Why is that post-launch tracking important?
It helps satellite operators find their newly launched satellites quickly and avoid immediate collision risks. Reduces the number of lost satellites that just become more debris. And we also saw that NASA is partnering more closely with companies like Leo Labs, using their high-precision radar data to boost NASA's own collision avoidance capabilities. These commercial tracking services are becoming essential.
So technology and services are evolving to manage the risk. What about rules and regulations?
Also moving, thankfully. The research noted a recent U.S. executive order aimed at streamlining regulations for commercial space activities. And the FAA is drafting rules for drones flying beyond visual line of sight, BVLOS.
How does that relate?
It shows governments are trying to keep pace, foster innovation, reduce the bureaucratic hurdles, whether it's drones or space launches, trying not to stifle progress.
Good to hear. Any other big considerations for the future?
Well, the ongoing international competition, definitely, especially the race back to the moon. Cybersecurity is another big one. As satellites become more complex and networked like NTS-3, protecting them and their signals, like GPS, from interference or attack is paramount. And as we touched on with the fission power, just managing power for these longer, more ambitious missions is always a challenge.
Okay, so pulling it all together, what's the future outlook based on this week's developments? What are the key trajectories?
Synthesizing the research, a few things seem clear. First, designing for serviceability like those docking plates is likely going to become standard for new satellite constellations. We'll see more partnerships between operators and servicing companies.
Makes sense. Sustainability.
Second, the data we get back from NTS-3 is going to heavily influence the next generation of GPS satellites, known as GPSS. Expect more reprogrammable tech, better anti-jamming.
Okay.
Third, if those bioprinting and metal manufacturing experiments on the ISS yield good results, and it looks promising, expect a surge in investment in that specific commercial sector, high-value products made in space.
The economics start to work.
Potentially, yeah. And finally, all eyes will remain on 3IATL as it swings by the sun in October. The data from Webb especially could give us unprecedented insights into its composition, its origin. Basically, a peek at the raw materials of another solar system.
Just fascinating. What an incredible range of developments just in 1 week. From an ancient visitor from another star sparking all this curiosity to literally building the future in orbit with new manufacturing techniques, securing vital communications, and taking real steps toward making space sustainable.
It really feels like a transition point, doesn't it? The research collectively points towards humanity moving beyond just, visiting space and actually starting to systematically build a permanent, resilient, economically viable presence out there. It feels like things are maturing.
So thinking about our listeners, what possibilities do these huge leaps in space tech unlock right here on Earth? Maybe new medicines from bioprinting, truly global connectivity.
Or even just a better understanding of our place in the cosmos from studying things like 3I8LAS.
Lots to think about. We definitely love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, drop us a comment. Let us know what you think about this week's progress in space. What are you most excited to see?
Yeah, let us know.
All right, that's all the time we have for Tomorrow Unveiled today. Thanks for tuning in.
Thanks, everyone.
We'll be back soon with another look at what's next.